The Arizona desert sprawls across the American Southwest, a realm sculpted by time and the relentless forces of nature. Its geography is a tapestry of vast sun-baked plains, jagged mountain ranges, and labyrinthine canyons carved by ancient rivers. Here the land is painted in hues of ochre, crimson and gold, a testament to the region's volcanic origins and mineral-rich soils. The ground itself is a mosaic of cracked clay and gravel where only the hardiest plants take root. Rainfall is scarce, often less than 10 inches a year, and when it comes, it arrives in sudden torrential bursts that reshape the land in moments. By day, the sun reigns supreme, driving temperatures to a blistering 113 degrees Fahrenheit. The air shimmers with heat and the horizon wavers in a dance of mirages. Yet as darkness falls, the desert transforms. Temperatures can plummet to a chilly 50 degrees, a dramatic swing that tests every living thing. This daily cycle of extremes shapes the rhythm of life. At night, the desert breathes, releasing the heat of the day and welcoming the cool, star-studded silence. The flora and fauna here are marvels of adaptation. The iconic saguaro cactus, towering up to 40 feet, stores thousands of gallons of water in its pleated trunk, while its spines provide shade and deter thirsty animals. Prickly pear, agave, and creosote bush thrive with deep roots and waxy leaves, each a master of water conservation. Among the animal kingdom, survival demands ingenuity. The kangaroo rat never drinks water, extracting moisture from seeds. The Gila monster, one of the world's few venomous lizards, stores fat in its tail to endure lean times. Jackrabbits use their oversized ears to dissipate heat, while burrowing owls escape the sun in underground dens. Camouflage is a common strategy. Many creatures, from the horned lizard to the rattlesnake, wear the colors of the earth, vanishing into the landscape to hunt or hide. Movement is measured and deliberate. The western diamondback rattlesnake glides silently, conserving energy and avoiding the midday sun. Nocturnal hunters like the scorpion emerge only after dusk, their bodies glowing under ultraviolet light. Defense is paramount. The rattlesnake's rattle is a marvel of evolution, a series of interlocking keratin segments that produce a warning buzz, deterring would-be predators. Other animals rely on armor, venom, or speed to survive. Predators and prey are locked in a perpetual contest. Red-tailed hawks soar on thermals, scanning for movement below. Coyotes and bobcats prowl the shadows, while roadrunners dash after insects and small reptiles. The Arizona desert is a living web, each species playing a vital role. As a keystone species, the rattlesnake helps regulate populations of rodents and small mammals, maintaining the delicate balance of this ecosystem. Pollinators like bees and bats ensure the survival of countless plant species, while decomposers return nutrients to the soil. This is a land of resilience and wonder, where every sunrise brings new challenges and every sunset marks another day of survival. The Arizona desert is not just a place. It is a living, breathing testament to the power of adaptation and the intricate beauty of nature's design. The rattlesnake exemplifies evolutionary refinement, its anatomy meticulously sculpted by millennia of natural selection to thrive in arid, resource-scarce environments. Its integument, or skin, is covered in keeled scales that not only provide protection from abrasive sand and rocky terrain, but also aid in moisture retention, a critical adaptation for desert survival. The cryptic coloration, ranging from sandy browns to muted greys, serves as disruptive camouflage, allowing the rattlesnake to remain virtually invisible against the substrate, an essential trait for both ambush predation and predator avoidance. The muscular system of the rattlesnake is highly specialized for serpentine locomotion. Its axial muscles contract in coordinated waves, enabling lateral undulation, sidewinding, and rectilinear movement. These methods of locomotion minimize contact with the scorching desert surface, reducing water loss and thermal stress. The vertebral column, composed of over 200 vertebrae, provides both flexibility and structural support, allowing the snake to coil tightly or extend rapidly during a strike. The rattlesnake's most formidable adaptation lies in its venom delivery apparatus. The maxillary bones are hinged, supporting long, hollow fangs that function as hypodermic needles. These fangs are connected to venom glands, modified salivary glands, capable of producing a complex hemotoxic venom. This venom contains proteolytic enzymes, metalloproteinases and phospholipases, which rapidly disrupt cellular membranes, degrade extracellular matrix, and induce coagulopathy in prey organisms. The venom not only immobilizes, but also initiates extracorporeal digestion, liquefying tissues for easier ingestion. The strike mechanism is a marvel of biomechanical engineering. Elastic ligaments and specialized jaw musculature allow the fangs to fold against the roof of the mouth when not in use, then snap forward in a fraction of a second. The strike is powered by rapid contraction of the epaxial muscles, delivering the venom with pinpoint accuracy. This system ensures minimal energy expenditure and maximum predatory efficiency. Venom metering is another sophisticated adaptation. The rattlesnake possesses the neurological ability to regulate the volume of venom injected, conserving this metabolically expensive resource. A full envenomation is reserved for subduing prey, while a controlled, reduced dose or even a dry bite may be used in defensive scenarios. Defensive behaviors are further enhanced by the presence of the rattle, a series of interlocking keratin segments at the tail's tip. When vibrated, these segments produce a distinctive warning sound, serving as an aposematic signal to potential threats. This auditory display is an evolutionary innovation that reduces the likelihood of physical confrontation, thereby preserving both energy and venom. Sensory adaptations are equally advanced. The rattlesnake's loreal pits, located between the eyes and nostrils, function as infrared detectors capable of perceiving minute temperature gradients. This allows the snake to accurately locate endothermic prey even in total darkness. The vomeronasal organ, or Jacobson's organ, further enhances chemosensory tracking by analyzing scent particles collected by the forked tongue. The cranial kinesis of the rattlesnake's skull enables remarkable jaw expansion. Ligamentous connections between the quadrate and lower jaw bones allow the mouth to open up to 150 degrees, facilitating the ingestion of prey items much larger than the snake's head. Once consumed, the prey is propelled down the esophagus by sequential muscular contractions or peristalsis. Postprandial metabolism is highly regulated. Following a substantial meal, the rattlesnake's metabolic rate can increase by up to 40 times, a phenomenon known as specific dynamic action. Basking behavior is employed to elevate body temperature, accelerating enzymatic digestion and nutrient absorption. The ability to endure prolonged fasting is facilitated by a slow metabolic baseline and efficient nutrient storage in the liver and fat bodies. The rattlesnake's osmoregulatory system is finely tuned for water conservation. The kidneys produce highly concentrated urine, and the cloaca reabsorbs water from fecal matter, minimizing fluid loss. This physiological economy is vital in the desert's unpredictable cycles of abundance and scarcity. Every anatomical and physiological feature of the rattlesnake is a testament to evolutionary ingenuity, from its cryptic scales and specialized musculature to its advanced sensory organs and venom apparatus. The rattlesnake stands as a paragon of adaptation, an apex predator, perfectly attuned to the challenges of its environment. The rattlesnake's true genius lies in its extraordinary hunting toolkit, a suite of adaptations honed by evolution for survival in the unforgiving desert. Specialized heat-sensing pits, located between the eyes and nostrils, allow rattlesnakes to detect infrared radiation. This means they can see the body heat of warm-blooded prey even in total darkness, a crucial advantage for nocturnal hunting. The forked tongue is another vital tool. By flicking it in and out, the rattlesnake collects microscopic scent particles from the air and ground, delivering them to the Jacobson's organ in the roof of its mouth. This organ analyzes chemical cues, creating a detailed scent map of the environment. The tongue's split design is key. By comparing scent strength on each fork, the rattlesnake can determine the direction of a scent trail with pinpoint accuracy, tracking prey across sand and stone. Its eyes are adapted for low light, with vertical pupils and sensitive retinas that detect the faintest movement at dawn, dusk, or under the cover of night. This visual acuity helps the rattlesnake spot even the slightest twitch of a rodent or lizard. Camouflage is another weapon. The rattlesnake's patterned scales blend seamlessly with sand, rocks, and brush, allowing it to remain invisible to both prey and predators. This natural disguise is essential for its ambush strategy. When prey comes within range, the rattlesnake strikes with lightning speed, often faster than the blink of an eye. Its hollow fangs inject potent venom, a complex cocktail of enzymes and toxins that immobilize and begin digesting the prey from within. In the Arizona desert, these adaptations make the rattlesnake a master predator. Whether stalking a kangaroo rat under the stars or lying in wait for an unwary lizard, its sensory arsenal, venom, and camouflage ensure that few creatures are safe from its silent hunt. 2 to 4 times each year, the rattlesnake embarks on a remarkable journey of transformation, the shedding of its skin. This process, known as ecdysis, is not merely a routine event, but a vital act of renewal that ensures survival in the harsh, unforgiving desert. Shedding serves several crucial purposes. It removes harmful parasites and accumulated debris from the old skin, and it allows for growth, accommodating the expanding body beneath. The process also repairs minor injuries and replaces worn scales, maintaining the rattlesnake's protective barrier against the elements. Yet, this act of renewal is fraught with risk, as the rattlesnake becomes especially vulnerable to predators and environmental threats during this time. The shedding process begins internally. Specialized cells in the rattlesnake's skin secrete enzymes, creating a thin layer of fluid between the old and new skin. This separation causes the snake's colors to fade and its eyes to turn a milky, opaque blue, a sign that the outer layer is loosening. During this pre-shed phase, vision is severely impaired, leaving the rattlesnake nearly blind and sluggish. Its senses are dulled and its movements slow, making it more susceptible to danger. Instinctively, the rattlesnake seeks out a secure, hidden refuge, perhaps beneath rocks within a shaded crevice or under dense brush. Here it remains motionless, conserving energy and minimizing exposure to predators. This period of concealment is critical, as the snake's dulled senses and sluggishness make it an easy target. When the time is right, the rattlesnake initiates the shedding process. It rubs its snout against a rough surface, such as jagged rock or coarse sand, to split the old skin near the mouth. With slow, deliberate movements, the snake pushes forward, turning the old skin inside out as it wriggles free. The process is methodical. The skin peels away from the head, over the eyes, down the body, and finally off the tail, leaving behind a nearly perfect, translucent replica. Emerging from the old skin, the rattlesnake is renewed. Its scales are now glossy and vibrant, restoring effective camouflage and enhancing its ability to absorb and reflect heat. The new skin is more flexible and better equipped to protect against dehydration, parasites, and injury. Sensory organs, including the heat-sensing pits and eyes, regain clarity, sharpening the rattlesnake's perception of its environment. With each successful shed, a new segment is added to the rattle at the tip of the tail. This structure, composed of interlocking keratin segments, serves as a living record of the rattlesnake's growth and survival. The rattle's sound grows louder and more complex, amplifying its warning to potential threats. The physiological renewal brought by shedding is profound. The rattlesnake's immune system is bolstered, minor wounds are healed, and the risk of infection is reduced. The fresh skin enhances mobility and sensory function, allowing the rattlesnake to hunt, evade predators, and navigate the desert with renewed vigor. Ecologically, the act of shedding plays a vital role. The discarded skin provides nutrients for desert scavengers and decomposers, contributing to the nutrient cycle of the ecosystem. The rattlesnake's renewed health ensures its continued role as both predator and prey, maintaining balance within the desert food web. With its new skin, the rattlesnake emerges from hiding, moving with restored confidence and purpose. The transformation is complete, and the rattlesnake is once again prepared to face the relentless challenges of desert life. In this ever-changing landscape, survival demands constant transformation. For the rattlesnake, renewal is not just a fleeting moment, it is a continuous cycle, a testament to adaptation, endurance, and the intricate balance of desert life. In the harsh Arizona desert, the rattlesnake coils tightly, its tongue flicking, senses alert for danger. But even as a top predator, it faces a cunning adversary. The greater Roadrunner, a 2-foot-long marvel of adaptation, scans the landscape with sharp, intelligent eyes. Its long legs and zygodactyl feet, 2 toes forward, 2 back, are built for speed and precision. The encounter begins. The Roadrunner approaches with calculated steps, feathers sleeked back, crest raised in anticipation. The rattlesnake rattles, warning, but the bird is undeterred. With lightning reflexes, the Roadrunner darts in, jabbing at the snake's head and tail, always staying just out of reach of the venomous fangs. Its beak, sharp and strong, lands rapid, stinging blows. The rattlesnake strikes, but the Roadrunner leaps aside, wings flicking for balance. This dance continues: attack, retreat, feint, and dodge. The bird's agility is a product of powerful leg muscles and a lightweight frame, evolved for these high-stakes confrontations. As the minutes drag on, the snake tires. It strikes slow, its coils loosen. The Roadrunner seizes the moment, pinning the snake's head with a precise peck, then battering it against the ground to subdue it. This relentless assault is more than brute force. It's a display of evolutionary arms race. The Roadrunner's thick skin and rapid movements help it avoid venom, while its intelligence allows it to read the snake's every move. In this ecosystem, roles blur. The hunter becomes the hunted, and survival depends on adaptation and wit. Victorious, the Roadrunner swallows smaller snakes whole, gaining not just nourishment but precious moisture. An essential resource in the arid desert. For the rattlesnake, the Roadrunner is a foe that cannot be ignored, a living testament to the fierce, ever-shifting balance of desert life. In the heart of the Arizona desert, 2 formidable predators meet, each a master of survival in this harsh landscape. The Kingsnake is the rattlesnake's ultimate nemesis. The rattlesnake coils defensively, tail buzzing, fangs bared in warning. But the Kingsnake, immune to rattlesnake venom, is undeterred. With explosive speed, it lunges, aiming directly for the rattlesnake's vulnerable head. The rattlesnake strikes, but the Kingsnake's agility allows it to dodge, weaving around the venomous fangs. The Kingsnake releases a pungent musk, clouding the air and disorienting its rival. Seizing the moment, it bites down and coils its muscular body around the rattlesnake, beginning the suffocating embrace. The struggle is fierce. The rattlesnake thrashes, trying to break free, but the Kingsnake's grip only tightens. Each twist and turn stirs up dust, the 2 snakes locked in a primal contest of strength and endurance. Gradually, the rattlesnake's movements slow. The Kingsnake's constriction is relentless, cutting off air and blood flow. Once the rattlesnake is still, the Kingsnake begins the slow process of swallowing its rival whole, jaws stretching impossibly wide to accommodate its formidable prey. This epic duel is more than a battle for survival. It is a dramatic spectacle shaped by millennia of evolution. Each species has honed its strategies: the rattlesnake's venom and warning rattle, the kingsnake's immunity and constricting power. The kingsnake's smooth scales, powerful muscles, and resistance to venom make it the undisputed ruler in these encounters. Its senses are finely tuned to detect movement and scent, giving it the edge in this deadly contest. For the rattlesnake, the kingsnake is a foe it cannot intimidate or escape. Even the most desperate defense is no match for the kingsnake's persistence and strength. In this battle, only one snake survives. The kingsnake's victory not only secures its next meal, but also shapes the delicate balance of life in the desert ecosystem, keeping rattlesnake populations in check and maintaining the intricate web of desert life. In the heart of the arid desert, the desert woodrat, small, swift and resourceful, faces a daily struggle for survival. Though it may seem insignificant against the backdrop of endless sand and stone, this rodent is a master of adaptation, perfectly attuned to the challenges of its harsh environment. The woodrat's world is one of constant vigilance, where every shadow could conceal a predator and every sound might signal danger. Among its most formidable adversaries is the rattlesnake, a silent hunter whose venomous strike can end a life in seconds. Yet the woodrat possesses a remarkable secret weapon. Its blood contains a unique protein that neutralizes rattlesnake venom. This adaptation, honed over countless generations, allows the woodrat to survive bites that would be fatal to most creatures. It is a living testament to the relentless evolutionary arms race between predator and prey. But the woodrat's defenses extend far beyond its blood. When danger is near, it relies on acute senses, keen hearing, sharp eyesight, and an extraordinary sense of smell to detect the approach of a rattlesnake. At the slightest hint of threat, the woodrat freezes, blending into the landscape, or darts for cover with astonishing speed. The woodrat is also a skilled architect. It constructs elaborate nests, known as middens, using sticks, rocks, and especially cactus spines. These fortresses are not only shelters from the scorching sun and freezing nights, but also formidable barriers against predators. The dense, tangled walls bristle with sharp spines, deterring even the most determined rattlesnake from entering. Any rattlesnake attempting to breach these defenses risks injury from the nest's sharp armaments. The woodrat's home is designed with multiple escape routes and narrow tunnels, allowing it to evade capture and outmaneuver its attacker. The desert itself becomes an ally. The woodrat navigates its territory with intimate knowledge, using rocks, crevices, and dense vegetation as both cover and escape routes. Its agility and speed make it a challenging target, forcing the rattlesnake to expend precious energy in pursuit. Sometimes the rattlesnake relies on patience, lying in ambush for hours near a nest entrance. The woodrat, ever cautious, will pause and survey its surroundings before venturing out, minimizing the risk of a fatal encounter. Even with these defenses, danger is never far away. A single miscalculation, a moment's hesitation can spell disaster. The woodrat's survival depends on split-second decisions and the ability to exploit every advantage its environment offers. In moments of confrontation, the woodrat may even display defiance, standing its ground, vocalizing or flicking its tail to distract and confuse the rattlesnake. These behaviors, though risky, can sometimes buy the precious seconds needed to escape. The desert is a place of extremes where every creature must innovate to survive. The woodrat's blend of physical, behavioral, and ecological adaptations is a testament to the power of natural selection in shaping life for survival in this unforgiving realm. Predator and prey are locked in a perpetual contest, each shaping the other's evolution. The woodrat's ingenuity and resilience drive the rattlesnake to become a more cunning hunter, while the snake's relentless pursuit forces the woodrat to refine its defenses. Every encounter is a high-stakes test of strategy and survival. In the relentless desert, the woodrat's defiance and adaptability are its greatest weapons, ensuring that, for now, it remains a worthy rival to the rattlesnake in nature's ongoing battle for existence. The rattlesnake's greatest strength is its remarkable adaptability, a trait shared by many desert dwellers. In this unforgiving landscape, survival demands constant innovation, physiological, behavioral, and ecological. Each failed hunt or narrow escape forces the rattlesnake to refine its tactics. Just as the lizard's push-up displays warn rivals and the horned lizard's defenses startle attackers. If twilight hunting becomes too risky, the rattlesnake shifts to nocturnal ambushes, burying itself in sand to become nearly invisible. Scorpions and tarantulas, too, retreat underground, escaping the day's deadly heat and emerging only when darkness falls. Freshly shed skin enhances the rattlesnake's camouflage, making it even harder to detect. Other creatures like lizards and scorpions also shed, renewing their armor and blending seamlessly into the desert tapestry. The rattlesnake's heightened senses after shedding give it an edge in tracking prey and avoiding danger. Kangaroo rats rely on acute hearing to detect silent predators, while bats navigate and hunt with echolocation, mastering the night. When food is scarce, the rattlesnake slows its metabolism, surviving for months on fat reserves. The desert tortoise retreats into its burrow, conserving water and energy, while lizards bask only briefly before seeking shelter from the relentless sun. The rattlesnake can change its hunting times, diet, and energy use to match the desert's challenges. Coyotes and owls, too, adjust their routines, exploiting every opportunity the shifting environment offers. This flexibility, behavioral, physiological, and ecological, is the key to survival. Jackrabbits rely on speed and shade, while beetles harvest precious water from morning dew. In a world of extremes, only the adaptable endure. Even plants like the saguaro and creosote have evolved to store water and thrive where others perish. The rattlesnake's resilience is its ultimate weapon, shared by all who call the desert home. Here, adaptation is not just a strategy, but a way of life. As the desert awakens in spring, the rattlesnake emerges from its winter den, driven by an ancient instinct, the urge to reproduce. The warming sun signals the start of a remarkable cycle, one that has shaped the species for millions of years. Male rattlesnakes begin their search, traveling vast distances across the arid landscape, guided by pheromones left by receptive females. When two males cross paths, a ritualized combat dance unfolds, an elegant yet fierce display of strength and endurance. They rise up, entwining their bodies, each striving to pin the other to the ground. Only the strongest prevails. The victor earns the right to mate, passing on his genes to the next generation. This ensures that only the fittest, most adaptable traits are inherited, a process known as sexual selection, vital for the species' survival in such a harsh environment. Unlike many reptiles, female rattlesnakes are ovoviviparous. They carry eggs inside their bodies, giving birth to live young. After a gestation period of 3 to 5 months, the mother delivers a brood of up to 20 neonates, each perfectly formed, equipped with fangs and a small but potent supply of venom. For a brief window, the mother remains with her offspring coiled protectively around them. This rare display of maternal care in reptiles offers the vulnerable young a crucial head start, shielding them from predators and the elements, yet the desert's unforgiving. Predators such as hawks, coyotes, and even other snakes lie in wait. Extreme temperatures and scarce water test the resilience of every hatchling. Most will not survive their first year. Those that endure grow quickly, shedding their skin as they mature. Each shed marks a new stage in their development, and with every successful hunt, they hone the skills needed to thrive in this challenging ecosystem. As adults, rattlesnakes become apex predators of the small mammal world. Their heat-sensing pits allow them to detect prey even in total darkness, and their venomous strike is both swift and precise. By controlling rodent populations, rattlesnakes prevent overgrazing and the spread of disease, maintaining the delicate balance of the desert. This cycle, birth, struggle, survival, and reproduction, has sculpted rattlesnakes into masters of adaptation. Their resilience is a testament to the power of natural selection. The presence of rattlesnakes ripples through the ecosystem, supporting a web of life that includes predators, prey, and scavengers alike. Their survival is intertwined with the health of the entire desert community. In this sun-baked wilderness, the rattlesnake's legacy endures, an unbroken chain of life, death, and renewal, vital to the desert's very soul. Beneath the scorching sun and shifting sands of the Arizona desert, an intricate tapestry of life unfolds, woven together by countless interactions, dependencies, and delicate balances. At the heart of this web lies the rattlesnake, a creature both feared and revered, whose presence shapes the fate of many. As a predator, the rattlesnake exerts silent control over rodent populations, targeting woodrats, kangaroo rats, and pocket mice. Every ambush, every strike sends ripples through the ecosystem. By keeping small mammal numbers in check, rattlesnakes prevent overgrazing of fragile desert plants. This, in turn, preserves the seeds and shoots essential for insects, birds, and even larger herbivores. Yet the rattlesnake is not invincible. It, too, becomes prey in this dynamic system. Keen-eyed hawks, such as the red-tailed and Harris's hawk, scan the desert floor, ready to swoop down and snatch an unwary snake. The kingsnake, immune to rattlesnake venom, launches bold attacks, constricting its serpentine relative in fierce primal battles. Even opportunistic scavengers like the kit fox and the raven await their chance to feed on the remains. The rattlesnake's venom, so lethal to its prey, also has a wider ecological impact. When a rattlesnake strikes, not every hunt ends in a clean kill. Wounded prey, if not consumed, may become easy targets for other predators or scavengers, redistributing nutrients across the food web. Meanwhile, the rattlesnake's shed skin, uneaten eggs, and even its eventual death add organic matter, nourishing decomposers and enriching the arid soil. Competition is fierce. The Roadrunner, itself a formidable snake hunter, competes with rattlesnakes for similar prey. In lean years, when resources dwindle, these contests intensify, driving evolutionary arms races in speed, stealth, and cunning. Symbiotic relationships further bind the web. Burrows abandoned by rodents may shelter young rattlesnakes, while the snake's predation indirectly protects desert flora, which in turn supports pollinators and seed dispersers. Each link is vital. Remove one and the entire structure trembles. In the Arizona desert, survival is a communal endeavor. The rattlesnake's dual role as predator and prey anchors a network of life, underscoring the profound interdependence that defines this sun-baked wilderness. Here every creature's fate is intertwined, each life, each death sustaining the relentless pulse of the desert ecosystem. Beneath the patterned scales of the rattlesnake lies a secret weapon, venom, a product of millions of years of evolutionary refinement. This complex biochemical cocktail is more than a mere instrument of death. It is a tool of survival, adaptation, and ecological balance. Rattlesnake venom is a sophisticated blend of proteins, enzymes, and toxins, each with a specific purpose. Hemotoxins disrupt blood clotting and break down tissue, immobilizing prey and beginning the digestive process even before the first bite is swallowed. Neurotoxins, though less common in rattlesnakes than in some other snakes, can paralyze the nervous system, ensuring swift and efficient subjugation of small mammals, birds, and reptiles. The composition of venom varies not only between species but even among populations. This diversity is shaped by local prey types and environmental pressures, fine-tuning the venom's effectiveness. In the Arizona desert, where prey can be scarce and elusive, such adaptability offers a crucial edge. Venom is delivered through hollow, retractable fangs, precision instruments that inject just the right amount with each strike. For the rattlesnake, this efficiency conserves energy and minimizes risk, allowing it to subdue larger or more dangerous prey with minimal struggle. The effects of venom ripple outward, influencing more than just predator and prey. When a rattlesnake strikes, the outcome affects scavengers who may feed on weakened or deceased animals, and even the soil, as decomposed remains, return nutrients to the ecosystem. Venom also acts as a deterrent against would-be predators. While some, like the Kingsnake, have evolved resistance, most desert dwellers learn to heed the warning rattle, a sound synonymous with caution. Over time, the evolutionary arms race between rattlesnakes and their prey has driven remarkable adaptations on both sides. Some rodents, for example, have developed partial resistance to venom, forcing snakes to continually refine their chemical arsenal. In the grand design of the desert, rattlesnake venom is not merely a weapon, it is a finely tuned instrument of ecological harmony. It shapes populations, drives evolution, and maintains the balance upon which the entire web of life depends. Through its silent, unseen influence, venom ensures that the pulse of the Arizona desert continues, relentless and ever adapting. As the sun slips beyond the jagged horizon, the Arizona desert transforms. The scorching heat that once shimmered across the sand fades, replaced by a cool, enveloping darkness. In this twilight the desert's true heartbeat emerges, not in the glare of day, but in the hush of night. For the rattlesnake, nightfall is the signal to begin its silent hunt. Cloaked in shadows, it glides over the sand, its heat-sensing pits attuned to the faint warmth of a rodent scurrying beneath a bush, or a lizard pressed flat against a cooling rock. These pits, located just below the eyes, grant the rattlesnake a sixth sense, thermal vision, turning the darkness into a landscape of glowing silhouettes. But the rattlesnake is not alone in the night. The desert teems with life that shuns the sun. Kangaroo rats leap from burrow to burrow, their large eyes adapted for gathering every available photon. The lesser nighthawk swoops silently overhead, wings cutting the air with practiced stealth, feasting on nocturnal insects drawn out by the cool. Even the formidable tarantula emerges, its sensitive hairs detecting the tiniest vibrations along the desert floor. Each creature is a master of adaptation. The pallid bat, with its oversized ears, hunts scorpions by echolocation and sound. The desert woodrat fortifies its nest with cactus spines, deterring prowling predators. And the rattlesnake itself moves with patience and precision, conserving energy in the stillness, striking only when the odds are sure. Nocturnal life in the desert is a delicate dance, choreographed by necessity. Temperatures drop, reducing the risk of dehydration and heat stroke. Predators and prey navigate by scent, sound, and the faintest trace of movement. The night air, cooler and thicker, carries the subtle rattle of warning farther than by day, a soft percussion in the symphony of the dark. In this hidden world, survival depends on stealth and senses sharpened by evolution. The rattlesnake's cryptic coloration blends seamlessly with the moonlit earth, while its tongue flicks out, sampling chemical cues left in the sand. Each movement is deliberate, every pause measured, as both hunter and hunted rely on their nocturnal gifts. As dawn approaches, the desert's night dwellers retreat. The rattlesnake coils beneath a protective rock, the woodrat slips into its fortress, and the nighthawk disappears into the pale light. The desert returns to stillness, awaiting the sun's return and the next chapter in its endless cycle of adaptation and survival. Beneath the timeless rhythms of night and day, the Arizona desert faces silent, shifting threats. The delicate balance that sustains the rattlesnake and its fellow inhabitants is increasingly tested by forces beyond their control. Rising temperatures, driven by climate change, alter the very fabric of the desert. Extended droughts parch the land, shrinking water sources and stressing plant life. As cacti wither and grasses retreat, the foundation of the food web weakens. Prey becomes scarce, and the rattlesnake's hunt grows longer and more uncertain. The altered climate also disrupts the timing of key life events, emergence, breeding, and hunting, forcing all creatures to adapt at a pace nature never intended. Invasive species, too, reshape the desert's tapestry. Hardy grasses from distant lands invade, fueling wildfires that burn hotter and more frequently than the native landscape can withstand. These fires sweep through the brush, uprooting the homes of woodrats and consuming the cover that once shielded the rattlesnake from both heat and predators. With each blaze, the intricate patchwork of shelter and prey is redrawn, often to the detriment of desert specialists. Habitat loss silently encroaches from the edges, as the desert fragments corridors that once allowed safe passage between hunting grounds and nesting sites vanish. Isolated populations of rattlesnakes become more vulnerable to disease and genetic decline. The web of life grows thinner, each strand stretched by the loss of space and resources. Yet, even as these threats loom, the desert's resilience endures. The rattlesnake, shaped by millennia of adversity, continues to adapt, seeking shade in new places, shifting its patterns and relying on senses honed for survival. But the challenges mount and the outcome remains uncertain. In this arena of extremes, the fate of the rattlesnake is tied to the health of the entire ecosystem. Every plant, every animal, every grain of sand plays a role in the survival of the desert's ancient hunters. And as the environment changes, so too must the strategies for survival, ensuring that the desert's story continues for generations yet to come.